Okay, hello everyone. I think we'll start this week's section, which is about GraphQL. So I think last Thursday we're talking about how to use the Django and build the Django's backend, the REST endpoints. For example, the ones we have built with a REST framework, but that's not the only format you can use it to communicate between the front end and back end. So today we'll talk about another, like a pretty much is more popular than the rest of the endpoints tool called GraphQL, but it's not the same concept as a GraphDB, so it's a bit different. Get yourself separate these two concepts. So the structure of the discussion today were from the web communication, the RESTful to the GraphQL, why we have this evolution. And then there is a tool we will use in our stack to deliver this like a GraphQL capability. And then is how we implement the GraphQL in the React in the front end. Then we can try to do some code demo and see you how to use it. I think it will be pretty short for this section today. So we will see if we have more time. We were starting to talking about the authentication and evaluation earlier because we have scheduled to have a full stack demo with a code like a end to end with a map. So we were trying to squeeze that in. First is about the web communication. So this traditional ways to do the web communication is HTTP like a protocol, which like the client side will send a request to a server will process the request and respond to the front end. That's a standardized ways when you request most of the websites, like what we have done last week with Django. So in your browser, when you visit your website, you basically from here, you send a request to the server side, and your server side, you're hosting your own Django server, and it will process the request and doing all the view things we have mentioned, return a JSON or some other format back to the front end, the client side, and rendering by the browser. So that's how it works, and it's still very popular today to work in this way. But there is a big problem here is like if you want to get the latest data, especially the updated data, you need to send another request to the server and put down the data. So in theory, if you have a highly updated application, then you basically need to DDoS your own server. So you probably send the request to the server every millisecond. So these things happen is not good because your server side will have a high server load. The CPU and the memory consumption probably will stay in a very high stage, and the latency probably will have problem because of these like bottleneck things, and the bandwidth, which is server like in the server side, that's kind of very expensive cost for most of the server providers. It will hold a lot of the bandwidth. So this like starting to evolve when nowadays we have so many diverse and very extensive UI interactions in the front end. And these things happen specifically like in my previous companies, we have a developer trying to, so we need to pull a lot of data from the backend about our heart, different vessels. So the developer there was trying to spin up 2,000 requests to the server at the same time. And because of this like wrong behavior, you can see the browser basically is frozen because the TCP request from the front end to the back end is also very highly like a resource consumable behavior. And then the backend, you can see a very large spike from 0% of the CPU usage to a very high one. Even we have a very large like a component in the backend in the AWS is starting to scale up with 16 like containers. It still cannot handle that. So these kind of problems and mistakes happen in the real life. How we solve that is we starting to have a new protocol comes out. It was proposed in 2008 and standardized in 2011. It's called WebSockets. So the WebSocket connection will persist the connection from the front end to back end as this like a diagram was shown. So when the client initiates a connection to the server side, the connection will be persisted, and you can send the message from the binary direction. So different from the HTTP, just is one direction you request and it return back. It's a one-off behavior. This one you can have like it's more like you have a bridge between your like a browser with a server, and you can keep in doing the communications between them. In this way, you basically have lower latency because when you have an update, you don't really need to keep pulling the latest data from the backend. The backend, the server side, can send an update to the front end. In this way, you don't need to like DDoS your server. So it's getting very popular when it's first was being released. It's perfect for the live chat application. The ChatGPT definitely is using this one, and a lot of the chat applications like the WhatsApp, WeChat, or the Messenger, they're all using this protocol. And for the gaming, is the same thing. Like because gaming, you wanted to have the low latency, and if you go to the like some of the news website, for example, W Today, they have the live like a podcast. Then normally in the backend, what they are using is the WebSocket connection because they can push the latest information to your side. Don't request you to doing the refresh the button in the browser, which will save a lot of effort. So it's not a really idea for what's the rest was like was good at. For example, the file upload is still a limitation for the WebSocket. You want to be able to send a file very easily. You still can do that, but it's not really ideal to send it through the WebSocket connection. And evolving from that, recently, actually, because we're talking about the AI and AI for stack, actually, recently, there is a new protocol was being released by the Cloudy. So it's called MCP. So you can see here, like the HTTP and the WebSocket, and there are some other protocols actually more and more popular on the market, like RTP. But this kind of protocols is used for the browsers and the server. But in this AI area, if you want the AI agent or the large language model be able to access your private data, they either will send like if we stick to the original way, they need to send the web API to call it. But nobody, if you don't really have a good documentation about your data, nobody really know which API they should request to get the latest data. You still need a human being able to access the data, like help you access data. That's basically the role's title for the data engineer. And what's the Claudia was proposed, this kind of concept is allowing the large language models being able to use a standard protocol to access your local resources. So it's very interesting and very new things comes out. And my personal opinion is this one we're definitely evolving very quickly. And we probably need to use this like later in next year. But like that's just for the context, get you like familiar with there is something new comes out. And some of the comparisons between these three protocols. So you can see like the main differences between the WebSocket and the HTTP is bidirectional user cases. So the server side, you should still can send the message to the like client side. And some of the best practices, like if you have a very simple application, like you want to just present some data and data is statical, you can just use the HTTP. But if definitely have some rare updates, or you have the problem with like a latency load, then probably think about the WebSocket. We will show some demonstration later to show you like how to use a WebSocket and why this one will evolving. And this MCP, you probably should get alerted when you see some like a good libraries was being pushed out. They probably will come very, very quickly. And we just talking about is from like there are 7 layers of the internet communication. Just what we are talking about is from the communication layer. So how the data was being communicated. But in the application layer, like how they've been presented to the developer actually is these two concepts, which is from the RESTful to the GraphQL way. So what is a RESTful API. We have already mentioned that in last Thursday's section, and we actually already implement that to the demo in last Thursday's demonstration. So basically, is like is a pattern or design pattern for you to based on the HTTP protocol to do the data communication. All of the results of the data communication will be identified by the URL. For example, here, you want to get the user wants information. The client side will send a request get users want, and the server side will return a JSON with the information about this user. This is called RESTful. And there are typical different endpoints. We actually also implement this last week is with help of the REST framework provided by the Django. So you can see you can get all of the users via this way. This is all standardized. And if you use the Django's REST framework, you can automatically get that. If you haven't done the homework for last Thursdays by yourself, try to view last week's recording. We actually do it manually step by step and showing how to do that. So you should be able to follow it and get that done. And but there is a problem with REST. For example, like most critical one for one of my recent development is I have a table. One of my tables field is a JSON field, and I store probably 100 MB of the data in that specific field. And when I'm trying to present something about this table, I don't really need that field to be pulled back to my client side. So, but if it's a RESTful endpoint and I want to get the data from that specific endpoint, I have no choice. The data will definitely return to the client side. And because of this data, large data like size, the latency definitely will be increased. So this is not ideal. So the problem is then, can we find a way when I want to just get the data for a specific field, I request in the URL and the backend will depends on my request, return the specific field to me in the front end. We definitely can do that if we put some parameters in our URL and in the backend, they were based on the URL, like the parameters and return the specific data to the front end. You definitely can do it that way. However, it's not really a scalable way, which means if you want to do it this way, you need to write a lot of code by yourself. Then another scenario is, for example, if I want to get the data about a specific user, then I have a table about the localization for this user. If I want to get, also we probably have a profile table for this user. If I want to get all of the information for this specific user, I probably need to at least file 3 requests to the backend and get the data back, which is also not that ideal. So like this will get the front end developers very panic. And if the back end people actually doing some changes, for example, they updated the field and updated the endpoints, and for some situation they haven't noticed the front end developers, what will happen? The application will crash, right? So this kind of things actually popping up when your application getting more and more complex, which kind of request for new changes for us. Then this actually like get the bone of the GraphQL. It's a different query language for the APIs. You only have one URL endpoint. So if you want to query the data, you only have one endpoint to query. For example, here is /GraphQL. And then like this is developed by the Facebook from the 2012. So Facebook actually doing a lot of pretty good things. For example, they released a PyTorch is the most popular like machine learning module. So they proposed these concepts in 2012, and then it's been like public available in 2015. With this kind of the ways, you basically have the capability to fetch the data based on your request. So this diagram is a demonstration about how it worked. So the client side will send a query to the GraphQL end, and there is only one endpoint for it. For example, here you have 6 of it, but in the GraphQL world, no matter what the model it is only have one request endpoint. And in this query, you basically specify what's the table I want to request and what's the field I want to request. and it will just return the field and the table you requested. So in this way, you don't really have you only have one request for multiple diverse data requirements, and also you only have one request and the precise the data you want, it will be returned to the front end. So the example I mentioned before won't is the problem will be solved here, because if you are having the request the field of the data, which is like a 100 MB, then this large data transfer between over the internet won't happen. So this is example and a comparison. For example, here, if we want to request the post followers and the users profiles from the backend, in the REST world, you have 3 requests. But in the GraphQL world, you basically do something like this. You declare a query and you specify the ID you want to do the query, and the name of it, the post, and what's the post information you want to query out, and what's the follower's name you want to query out. And this one request can get all of the data being pulled from the backend simply and easily. So, and also there are some other benefits. So you have less of this application side of things. Because of one request, you definitely have all the wins. Also, you have better developer experience, because for now, you can see it's directly connected to the database. So what the database looks like, it will be showing up to the front-end developers. So front-end developers doesn't really need to battle with the back-end developers, or it will give you some freedom to do the full-stack development. And we just showing is querying, but in the GraphQL operation, there are actually 3 concepts. Query is the same thing concepts as the get. So in the get, you basically fetch the data from the backend. It's a reader behavior. And if you want to create, update, or delete the data, in the GraphQL world, it's called a mutation, which means you specify you want to create a user, or you want to update a specific user, or you want to delete a specific user. These ways will allow you to do the a CRUD. This will allow you to do the CUD behavior. Some of the example is like this one here. And there are the third one is called subscription. This is something actually the REST endpoint cannot do, but originally we will implement it by the socket. So the WebSocket will be implemented here, and the front end, if they're doing the subscription, and the other things here are the same. And then when you're trying to update the name of the user, the front end data will be sent a data update to the front end. Front end will know, okay, you have a updated data there. So this subscription mode, operation mode, is actually being implemented in the background by these WebSocket things. And I think I'm in the wrong page. Okay. Yeah, when you're trying to have a lot of complex data relations, or you have mobile applications, or you have microservice architectures, then this GraphQL basically is a thing you should switch to. And in our full stack, this GraphQL Hasura things play a very important role when you're trying to deliver the application very quickly. We will show you later. So we come to the Hasura. So why this Hasura was kind of being developed and proposed, the reason is because this challenge, the GraphQL implementation challenge. So we can see from the previous talk is the GraphQL concept was being proposed quite late, it's been proposed in 2012 and then implemented, released by the Facebook on the 2015. And I think Facebook actually released it in their API endpoints. So, and also the library package for different programming languages is heavily, I think, related on the load. So for other languages, we can see the benefits from this, and we want to get that implemented in our applications later. However, for most of the languages, like the Python, C#, or the other stuff, you need someone go there and implement a package or SDK for you to be used and hook it to your database and get the resolvers endpoints, GraphQL endpoints being implemented. But it's a pretty new thing. So it will have the chance, like what will happen now, why the NameChain and the Llama Index was doing. So they see the gap of the implementation. So they're trying to build a tool to help people to doing that. Basically, is hooking the GraphQL concepts with your real data. And then in the early stage of this GraphQL implementation, for example, actually trying to implement GraphQL in the Python, I find out it's very hard to implement the whole GraphQL things with your database by yourself. For example, the rest for endpoints we discussed last week, we can see we actually just spend probably 20 minutes. We bring up all of the endpoints easily because it's already have a very good support from the community, the open source community have so many libraries. For the GraphQL, we are trying to implement with a WebSocket and all of the async libraries. I find out because it's pretty early stage, and when I'm trying to do it, I need to, even I can implement it in a very good status, but I need to spend much more time than the time I spend it to bring up the RESTful endpoints, which is not ideal for myself because I trying to deliver is application, not wheels like behind the application. So if there is a tool can help me get it done very quickly, I definitely need that. And also the GraphQL is a very new thing. So implement the backend of it will require a lot of effort and a learning curve. So in the early stage, there are a lot of challenges to get that happen in the reality. So, and for the Python specifically, like there is a WebSocket packages in the Python that was maintained by someone together with some async packages. Is writing in a pretty bad status, so it's not ideal for the production usage. That's in the early stage. It's like in the early stage, the problem why like the GraphQL's implementations in the Python is still the same problem actually today in the Python. So this is where the Hasura comes from. So it's actually an engine sitting from between your client side, which is a browser side, with a database side. So your GraphQL query comes to this Hasura engine, it will be translated to the SQL. And especially as we discussed in the database section, the SQL actually being optimized. So it means your query from the database will be pretty fast because they have a lot of experts do it for you in the background. And also it's writing in the Haskell. Haskell is a language which was famous for its good performance, which will make it like a highly compatible on this market because all of the application you're trying to deliver, you want the performance will be good. And the Python famous for its like a bad performance, even is acceptable for most of the application, but still like in the edge cases or the highly the application with a lot of users, then you have a problem. And this Hasura also have the built-in elaboration functionalities and the caching functionalities makes even perfect for you in the production. So you can see like the benefits it was doing, and also as I said, it's also have this like a subscription capability was being built in here. And for the developers, you don't really need to implement the GraphQL engine by yourself. They will do it for you. And all of these documentation things and like a CRUD things after you define the database tables, they also do it for you, which means you can deliver the application quickly. Like in our two like a section here today, 2 hours, we definitely can deliver a real-time dashboard being updated when there is changes in the data. So this is Hasura's data architecture. So it will have like a front-end interface for the user or the front-end application's query, which called the GraphQL API. And the data will be sent to the GraphQL API and into a query planner. Query planner will looking into the authentication model to make sure the guy who sent the request here actually have the permission to operating. And then it will go to the metadata to see which table he needed to go to there to do the like a query and a search. And then this query planner will transform this GraphQL query into the SQL query and execute on the database. And the data will return back to the query planner. The query planner will kind of doing the serialize, get the data into the JSON format, then return to the front end. And underneath it, like when we say the WebSocket things, it means in the database you have some changes. The front end need to be pushed some update. So the communication layer was using the WebSocket that we mentioned before, but the trigger itself, like when you update something, it should trigger something, right? So the trigger itself is using a database level trigger. So database have a functionality called a trigger. I'm not sure whether the relational database have mentioned that or not, but that's something was kind of trigger all the behaviors downwards to get the WebSocket subsegregation behaviors being implemented. And this is like a pretty simple like architecture you can see. And later when you use it, like if you are confusion with some concepts, always goes back to this kind of diagram. And Hasura's how you doing that one from the schema to the API. So basically you need to do is something like this. In a database like a SQL query, you create a database, and then Hasura will automatically generate something of this, declare the types of this field based on what you declare here for the database schema. So it's also have this typing capability as we mentioned earlier. So these are all the functionalities, the automatically CRUD and the real-time subscription and relation extractions we will show you in the demo later. For the security one, subsequently mentioned it is the Hasura actually have the row level security, which means in the front end, if you have a user being authenticated and he want to access some data, you can restrict which row of the data he can access and which row he cannot. And building on top of that, you can also specify these types of the rows, which columns of the data it can access, which columns it cannot. So in this like a design, it's basically matching the most critical or like harsh requirements from the market. It can achieve the row level and the column labels security permission control, which means in any of the applications you want to get this applied, even the medical one, it still should meet all of the governance requirements. And there are some other advanced functionalities. For example, you have REST endpoints. You want it being unified in one endpoint, being curable. You can use this remote schema things. And if you want to have some update of the data and you trigger some actions and update something else in the webhook with, you can also specify that. So if you have more functionalities or features required, you can check this like advanced concepts. So we talked so much about these GraphQL things and Hasura, what it actually looks like and what it looks like in the code. This is an example. So you can see in the left side is a query itself. In the right side, that's the data being pulled back from the client from the server side. So I can give you guys a real-time demo. So this is the interface of the Hasura. And if you haven't, if you, we actually have that in our clients, like a full stack setup in the week before. So when you trying to type in localhost 8080, you should see some interface like this. And then it will ask you for some like a admin secrets, which is the one declared in the Docker Compose file, and you should find out that and type it in, and then you will be able to see some pages like this. So when you create some data in the database, you should be able to see the tables from here. For example, because this backend actually is running on top of the Django, Django have so many tables being predefined. So if you want to be able to get the front end query this table, then you just click the track. And after you click the track, it will be showing up on the left here. And you can see all the data in that table being shown up here. We haven't do any permission like a control here. We will talk about this later, but after this step, when you go to the API, trying to do some query or trying to see whether you can query that table. For example, I think we just get the authentication permission table being tracked. So you want to know all of the information about it, you basically can query it back. So you can see we have that many tables for the authentication permission here. I think it's 10 records. And this one actually give us more actually. Oh, it's been pagination. So it's have the built-in pagination. So you have more than 10 columns. So you can see this right side here actually being curable by the front side and side. And the beauty of it, when I say I can doing it on demand is, for example, I find out I don't need the content type ID. I just delete it. Then front end will get the data without this content ID. And if you wanted to do the pagination directly in the front end, then you just set the offset. Then you can see starting from the 11 one to do the querying. And you can also limit it how many data you get like a fish in one query. So you can see limited to 10, then it's only have 10. Then if we say offset is 0, and then we get it, so we get it query again, it will query the data from 0 to 10, which means in this way you also have the like a native support out of box for the pagination. And you can do some other more advanced query, for example, distinct on. It actually will be translated to the analyze to the SQL. So this is explanation level about what we mean in the very beginning. The query from the front end, it will be translated to the SQL query. So the SQL query actually is being translated like this one. And you can also see the database execution plan and the real time, how long it takes to get the query being applied. This is also the concept that we discussed in the database section. So if you feel like your database have some problems with some specific query, you need to analyze whether it hit the proper index. And the GraphQL actually have that built-in capability. So if you find out one of your query in the GraphQL is very slow, you basically click this button and it will tell you what's the SQL query is running and why is slowing down, in which section is slowing down, and you can do some corresponding improvement in the database or in your query itself. So that's one of the functionalities you can get. And sorry, let's see. For the mutations we just mentioned, well, if you want to do the mutations, you can see here you have the mutation. But I probably don't want to update this table for the mutation here, but we can do some other mutations. So you can click the add. So you can see if you want to do the delete, you click it and you say what's my ID equals to, if it equals to 1, and then if you want to delete it, you click this one, it will delete it because it will be translated to a SQL query. But that's my production environment. I probably don't want to do that. And then when you're trying to insert something into the database, you can do this one as an insert, and then you can specify some parameters like the ID here, and it's big int, and it's required. And then you can mention it here, big int. And you can put your query parameters here as like your ID is 10. And then when you click this, it will also insert the data into the database. And update is the same thing. How you update it in the database, you can basically do it how you update it here. You just selected what's the where condition you want to update it from and what's the field you want to update it from. Then it's a where work. And for the subscription, it's actually very similar to the query. All of the differences is this declaration of the code. So just know when we're doing the query, here is query, but here we are doing the subscription. So which means it's subscribing from the backend. So I think here we have the con ID1 and the name is cannot add the logon entry. Let's go there to find this. This is the record actually in the database. Then let me change this field manually. I edit it, right? Wait a minute. Oh, okay. So you can see it's actually being updated, but it's on the bottom of it. Where is that? I have updated too. So it's called this one. Let's query. Oh, it's here. So it's been like reordered because I haven't give a very clear order in how it should order. But you can see I haven't refreshed this page. The data directly being pushed to the front end, which means you can do some real time like a dashboard here. So that's a quick demonstration about what's the GraphQL, like 3 operations, and what's the interface will be look like. So that's one of the examples. And for the GraphQL specifically, like when we're trying to do something here, tracking a specific table, we have mentioned in the earlier stage, like what's the differences between the table here as untracked status to the table here as a tracked status. The difference is actually is called like a metadata, which you actually can see it in the setting. So you can see when you click export to the metadata, and you're trying to open it. Try to open it somewhere in my IDE. So when you open it, you can see it's actually a JSON file, just the declaration about all of the tables or which of the columns is trying to tracking. So you can understand this metadata as a declaration about your GraphQL endpoints when it's trying to connect it to the database. So every time when you're trying to track a new table and update the authentications or authorization settings and also updating the relation tracking settings, then you should export your metadata and commit it into your repo and push it to the cloud. And then when you're in the production, you should get your latest metadata being applied it to the the Hasura server. So they will have the latest, the same status as what you have on your local. And the metadata just we're showing you is a JSON format, but it's basically a configuration file. So the more easier ways to manage it is actually the YAML file ways. So you should be able to have a folder in your like a GitHub somewhere. For example, for us in the Hasura is being initialized here. So that's actually the actions we are tracking and the settings. So if you go to the database, the default database, and go to the tables we are tracking, in the like I think last week's demonstration, you can see here is actually tracking the authentication user like stuff. So we will give you the demo how to update this and get this being tracked by the repo later. But you can see like you should be able to frequently checking your metadata every time when you're trying to do some update in the settings. Make sure you have committed these kind of changes and apply it to the server side. These are the commands you need to use when trying to export or reload or apply your metadata changes to your server or export from the server. It's pretty simple, just Hasura metadata apply or reload. And the best practice about the metadata, as we said before, you need to commit it definitely to your Git and do the version like tracking. And also this process should be hooked into the CI/CD procedure. So when you're trying to apply your latest metadata to your server, you shouldn't do it manually. You should get it to the CI/CD process, and the CI/CD process will automatically apply the latest metadata change to your application. In this way, you have the consistent things there. And there are some common issues. One is inconsistent status. So for example, in your metadata's local setting files, you have some changes, but another guy have another changes or manually change it in the cloud. When you apply it, it will give you the hint that is consistent. That shouldn't happen. If that things happen, you need to figure out which part is consistent and manually get the conflict being resolved. And there are something like the missing dependency, like if you are dependent on a table, there were missing dependency things, or permission conflict things, or relation errors. For example, relation be deleted later. You need to also remove that relation declaration in your configuration files. But these kind of things we will show you when we're doing the demo. And if you haven't encountered this, you don't need to worry about it. If you encounter these kind of things, you just need to map it to the common issues and then trying to search online or use the cloud to solve it for you. It's all very standardized and very simple to resolve. And then we have basically until now, what we have demonstrated is you have something similar to the Django. So basically in our architecture, the Django and the GraphQL is in the same layers in the backend. So it's the GraphQL basically is a replacement of the like a backend API server. Then the question is how we get the GraphQL being applied in the front end, especially in the in the Next.js or React.js. So there are actually several different ways. Basically, you need to have a client libraries to translate all your queries and manage all of the connections and caching things. You have several popular options, like the Apollo or URQL or the things below. But in the real world and the mainstream world, you actually only have these one options. That's the best option in the React and the Next.js when you're doing the GraphQL communications with the backend. So all you need to do in the front end when you're trying to do the GraphQL way, you need to install this Apollo client library and then set up the backend connections, specify what's the endpoint it is in the front end, and then it's done. You basically can use it. And the advantage of this is the Apollo itself is basically have the same edge as the GraphQL's like a standard. It's very rich functionalities. It have good communicated support, and also all of the functionalities as like a new user comes in, you basically can use it out of box, and there is no over engineering complex like a concept there for you to use. So it's a quite a good package and libraries. And how you configure it and do the setup, this is some example put here. So in the Next.js, the app.tsx file, you basically after install the Apollo client, you import it from it for the Apollo client and the provider. And then you initialize your Apollo client instance, specify your URI. For our local server, it's actually should be the local host 8080 and slash GQL something. And then you need to specify whether you want to use the cache or not. If you use the cache in the front end, if someone else or you yourself later you want to query the same data from the backend, it will first check in the memory cache. And if it is there, it will return it back to you, get it very fast. And then you just need to wrap the Apollo's client by this Apollo provider component on top of everything. That's it, that's done. And then in your like a React or Next.js applications, you can import this GQL and use query classes functions from this client, and then declare your query, this is the same thing as what we have done here in this interface. So you do the test here in this like a GraphQL interface, and then you copy this query back to your code and put it here. And then in your component, you're basically using this use query to query from these endpoints, and the data, it will have the loading arrow and the data like variables be returned. The loading will be true if it's still communicating with the backend. So you can use this if condition to make sure you show to the end user that are still trying to pull the data from the backend. The arrow will be like if your query here, there are something wrong, the arrow will be able to for you to do the debugging. And then if the loading is finished and there is no error, the data will be returned to the front end in a standardized way so you can access it. So for example, here, the data is being returned as data.user. And then because it's normally returned is as a list, so you're using the map function, and the user will have the map functions inside it. You use a user ID, username to show it. This will show you a list of the user in the front end by this query, and that's it. That's normally how you do it in the GraphQL when you're trying to build some components. And just now we showing is here it's a standardized query. So you don't have the capability to say, okay, I'm the user A, I just want to query the data for the user A. Then you definitely have that capability to do it. For example, here, I just want to query the user A. You can specify here with the variables and then put the variables in your queries as we just shown in the interface. And then in the fragment, like you probably have frequent used like a query chunk or section. For example, user profiles or user fields were normally related to the post and its emails and names. You can reduce it with these fragments functionalities. So this fragment will on the user object, like a table in the backend, and it will be something like this. And then you can inherit it from here. And if you have another query called get users, you can also reuse this fragment by them. And when you're trying to query it in the front end, all you need to do is in the user queries, you have the variables being declared, and then the variables will be passed to the backend to query the data. So this is all for our concept side. But I think the concept is quite new for most of you guys. I don't think any of our units in the university teaching anything about this WebSocket and GraphQL concepts. So it still will be hard for you to understand them all. So we will do a demonstration here. So the scenario is we will need to define a database data table, which we call it a data model. We will do this via the Django. As we have done last week. So in the Django, we use it to declare a model and create the table, apply the changes to the database. And then we will track it and track the created tables and relations in the Hasura, the interface I have shown you. And then we were showing up how you should be able to set up the Apollo client in the Next.js, and then how to use the WebSocket and HTTP queries in the GraphQL. This will also be the homework for you guys today, but we will give you a demonstration now. And I think the demonstration, like a scenario, I will give some like pretended context here. So what we will demonstrate here is we probably have like a AI multimodality large language model have a camera there. You viewing, for example, the hospital's triage room. So you wanted to keep being updated about how many people in the triage rooms, or like what's the status of the customer in the like a triage room. Then you probably have a table to tracking the like a time series changes in these rooms, and using an AI like a model to digest the images being taken by a camera probably, and feed it to the large language model. Large language model will output the information, and we save it to a data model. And the data model will be tracked by the front end component, and the front end will present that information there. So the first thing we need to do is we need to, in the database, in the GraphQL or in the platform side, we need to create a table to model what we have described it. So we were starting from the code we left from last week's demonstration. So if you haven't do the homework for last Thursday, I have pushed the latest code we have demonstrated to the cloud, and I actually sent the URL and links to our chat. So you can, if you haven't done that side of the homework, you can pour the latest main branch down and do the like starting from there if you want. But here we get the Docker being up, then we were starting with create a new app, which called a real-time dashboard, probably. So we need to first go into this Django component. And then, as we said last week, you use the command start app. Then we call it, let's call dashboard. Oh, I have something haven't installed, so I think I haven't built it. Yeah, I need to rebuild it. So like this problem happens because my previous image of the Docker haven't been updated with the latest requirements, the packages. So just now you can see it says there is no module named this, because last week when I do the demonstration, I manually install it inside of the container and put the requirement in manually in the requirement.txt. I haven't actually updated the image. This caused a problem why I want to create an app. It's showing the error. So to solve that, you have two ways. One way is you just go back and doing the Docker compose up and dash dash build. It will rerun all of the commands inside of the Docker file. So you will be able to get that requirements being installed. That's a standard way how you solve it. And if you want to solve this one quickly, you basically inside of the container, you manually install it. But that's you will still hit the same problem next time when you restart the container. So it's not recommended. So what I show you is a standard way. But if you are trying to hackingly get something out very quickly, you can do the first way I mentioned. So let's check what's the container ID of the. Okay, there are some problems with the database. Let's redo it. Like sometimes it will have some edge case problems. So what I doing to resolve the problem, like a developer was doing, is like just restart your computer. In our context, when we using the Docker Compose to do the development, is basically trying to run the Docker Compose down or Docker Compose up again. So let's go inside of this Django's container, and we create a new app for dashboard. And then it has created all the files here. We need to put it in the dashboard application. And then just now it says the context error, so it's failed because that is a setting like a file, which makes sense. Otherwise, if you change other files like we have done last week, the Django basically will restart here as like a watch loader. Yeah, so a lot of the Django was being up and running again. So we're only trying to get into the Django again. And then we just saying we want to have a table for the like a probably patient tracking. And then we don't really need the GPS, but we needed the time, which is created at and updated at, and a description about what happened here. And we want it to be all fair safe. So we doing this, and then we probably have a integer called a count, numbers of the patients currently in the waiting room. And then I want to just show the so this one where when you're trying to the define string things, when you're trying to pull the object from the database in the Django's models, it will give you some describable information if you define something like this, which will be easier for you to do the debug. The default things will just give it a ID for you to read. So it won't have much intensive information. So it's always a good practice to do something like this. And then, as we said before, after we define a table, then we need to make the migrations. And I need to run the command. Oh, sorry, my command is wrong, but the Django have the built-in to tell you what's the command. I'm missing an S. So after this, you can see it from here. It's actually creating a migration file. Then I need to do the migration apply, and it's getting applied it. And as we have done last week, we probably want to check it in the Django admin page. So we will do something like this. Patient tracking admin. So in this way, we should be able to get the table created. Then because our backend there are two things. One is our Django. If you have manually created the user and the password, as we have done last week, then you should be able to log in. And then you can see the table was being created here, and you have the description and the count field. So that's what we have done last week. And sorry, I need to move this. Then as a standard way we're doing last week, we were starting to go into the Django view page and starting to implement all of the REST endpoints. But here today, we needed to do the GraphQL, then it will be a different story. So we go to our GraphQL endpoints. And go to the data I showed you last week. So you can see here, that's all of the tables in the database. And we just created this table called the dashboard patient tracking, and we track it. So this table will be here. You can see it's being here. So if we created a test record in the database, if it's 10, in this way manually, so that's what it means in the define string. Define string actually defines how you see the data when in an object. So this one you can see there are some description information, which makes the developer experience better for the debugging. But currently you can see because we have a new data in the database, so you can see a new data here. And in the API side, then we're trying to query it from the database. Then you basically trying to do it in this way. So this will give you a dashboard tracking GraphQL query directly. So your endpoint is already ready. And then if you want to do the mutation, so let's try the mutation. You want to let's say you want to insert a record here, and the count is 10. The query at is actually null, and your updated at is also null. And you wanted to just return what have been created back and say what's the affected rows. And also you can use this on conflict field to doing this control about when there is a foreign key or unique field being conflict with a database, what it should do. So normally in the SQL query, we say create this field. If you encounter the conflict, then update all the columns of the table. This is how you do it in the SQL, but you can also do it in the GraphQL here. But basically, in this way, when I click it, it's creating a new field, a new data here. So we can try to check it in our database. So you can see the mutation actually doing the creation behavior already. So the create behavior was being done. Then we want to do a probably update. For example, here I want to update my second query. So I just doing the update. So I click it. The update was being shown here. And the where condition is the ID. I want to update the ID equals 1. And I want to set the description for the ID equals 1 is update from the front end. Then, and I want to return how many rows being affected by my update and the updated data back. So I click it. You can see it's affected one column, and it's returned the updated data back to the front end. And then when you back to check what's the database happening, you can see the first record actually be updated in the front end by our GraphQL queries here. And then the last request you probably want to do is you want to do the delete. Then how to do the delete? We don't really want to delete the user. We want to delete the patient. So you have two ways to do the delete. One is by the PK. PK means the primary key. So you just say, I want to delete the first one. So it will only delete one record if it's deleted by the PK. And if you want to delete based on a where condition, similar as when you delete it from the database. You write a query like a delete something something, then you basically use this one. So for example, we can use the delete operation here, and we set the condition is ID equals to 1. And then I want to know how many rows being affected and what's the data I'm actually deleting. Then you can do it in this way. This one, the bottom one is actually the wrong thing because I just trying to click this one, get them included. So you click this, you can see it's being deleted actually already. So when you go into to check what the database status, you find that data was actually gone. And the analyze things I haven't show you before because it's already being executed. So you won't be able to see the analyze things. But you can see in this way, you doing the delete also. And another good functionality in the GraphQL is you can track the relationships. For example, let's say we have another field in our database model, another table in the database called video or images, because each of the tracking record we want to associate with image. Then image data, we have a field called this. And then Django have the native support for the image field like ways, but probably you shouldn't use that because that's not. Nowadays we manage the static file on the S3, but at some point we can start with. So we create an image data, and then we using the formula key say which patient tracking record it is, and we use a formula key to tracking it. Then we don't need the description in the SR. So we define another new model, and we need to make another migrations. So what you do is make a migration, and you should give it a like readable name. What I give it here is image data, and then I do the command again. It's missing a S. Okay, this image field will require you to do something here. So for now, let's just give it a character field. This arrow says I need to install some other, maybe I should get them installed, other packages to get that work. And you should follow what it's saying there. So let's try to use what's saying to do it. And then we do the migration again and create a data migration file. And then we do the migrate. You can see it's being applied. And we also want to track this in our Django admin. Then you can see it's been, actually I haven't typed anything. It's all being generated by the GitHub Copilot. And let's check whether that's affected or not. You can see it's affected. You see this from the Django admin page. And I don't have any images to be uploaded to do the creation. But this demonstration is trying to show you what's the formula keys. Then let's go to the backend, the GraphQL side. You can see this is a table we just created and doesn't have any data, but it do have a formula key, which means you can see here, you can track the formula key relations between them too, the patient tracking and the image. So you click the track. What does that mean? It means in the front end, just now when we're doing the query for the Django patient tracking, if in the front end, you wanted to be able to view the images for each record, then you'll be able to do it this way. So you can see currently there is no data being related to this dashboard patient tracking, but I can create one. And let's see, create a save. It's been created. And then when I'm trying to do it again, you can see it's actually pulling the foreign key related data back to you. So in this way, if you have a ordinal key there and you want to track the relationship between them and very easily, you don't need to write any code. You just do it this way. You track it and it's there. And if you want to track it, because the relation is actually like a bidirectional, so you probably have the requirement from another side is you tracking from the image data back to the patient tracking data. Then you go there, you click them or you manually write them. You can see this is pretty diverse. So you basically from the image metadata going back to your dashboard tracking data. So you can easily tracking this like a bi-directional relations in the GraphQL ways without write or change any code in the background. And after this, we have all of the things ready in our hands for the front end to do the query, right? So, but we haven't done the thing is like we have just now we do a lot of changes in the metadata. So how we track that? I will give you guys a demo. So for now, I put all of the Hasura data under this Hasura folder. So you can see there is a folder in the Hasura folder called metadata or something like that. And in the Docker Compose file of this Hasura metadata, it was being mapping to the same folder inside of the Hasura container. Then what we will do here is we have manually changed a lot of like tracking metadata things in the Hasura end. Then we want to export all the metadata out. That's what we want to achieve. So how we do that? We go inside of the Hasura container with a bash, and we go to this Hasura folder. You can see the configure file is there. So they have the volume they mapping. That's what we expected. And then we have the Hasura command called Hasura-CLI because we use a CLI image. So you need to use these ways to use the Hasura command. Hasura metadata, then doing the export. It's being exported. So in the GitHub tracking, not sure why this is not working there. It should be, but let's go back to here in the status. So you can see here, we actually have two new files being created in the Git. So when you go to the data, when you go to here, you can see this image data and this patient tracking YAML is just being created by us manually on the click, but you export this metadata out. And next time when you're trying to use it in the cloud server or somewhere else, you just you can do the same thing. You go inside it, and then you have your CLI metadata apply, and that's it. You will be apply your latest metadata to the cloud side, and in the cloud side, you will be able to have this API ready for you to use. So under this way, then we have all of the backend work ready. So we have our models, we have the API endpoints was being done, all of the box tracking all of the diverse relationships. So we need to get that being implemented in the front end now. So let's pour out our code in, I think the 1 week before on that Thursday, we do the demonstration with how to set up the full stack. We actually set up the front end, the UI page. This is also the homework for the, I think for one of the sections. You need to go back to set up the Next.js on your own desktop by yourself. If you haven't done that, go to get that done or just pour the latest repo I have provided. But if you don't know how to do it, you just go to the Next.js website. The Next.js website will give you the instructions about how should you get started with creation things. So you can see they have the extensive like instruction here. And if you don't want to read the documentations, you should. But if you don't want to, you just say I wanted to initiate a Next.js project. And this one, the Cloudy will provide you how you do that. So you can see it's also give you the like all the capabilities, like how should you select each of the options when it's prompted. So after you doing this creation, basically you will reach the same status as myself here. So you will have a folder. Inside of the folder, you have a source file. The source file, you have the app, and the app, under the app, you have this page and the layout TSX. So that's basically what you controls what you see from the front end. And then you have this package.json things with all these different commands. And to get it being run, you can either run npm run dev or run like a young dev. They both works. And after you do this, you can open this page. You see this standardized like a page will be able seen by you. Like that's the default of what they have put there. So we trying to, I think we tried last time when we doing the demonstration, but we can try to change the pages to see what will happen there. So if we remove the footer in this page, then you should be able to see the footer be removed. Why? Probably we haven't have missed that. But let's also remove the main page and then refresh. You see everything gone. So let's put this is a test there. And then you can see this. So you can mapping like which file you change can give you the changes in the front end. So we get the front end basically running, up and running. And then as we said in our instruction tutorial, next thing we need to do is set up the GraphQL connection with Apollo. Apollo is what we choose. So let's see what the instruction Claudia was given. It's super simple actually. So yeah, that's what it is saying. So we will follow what it is saying. Is asking us first install the GraphQL and the Apollo client package. So we go there, we run the command it provided, and the node, okay, it's added the file. After you add that, actually you should be able to see it from here. So in the package.json, that's the same concept as Python's pipe file. So you can see it from here. The Apollo is being added, GraphQL is being added, and then we need to create a folder called a library and put the Apollo TS file inside it. So let's try to copy this. And we go to the source and create a new folder called lib. And then it's called Apollo client.ts. We do the same way. AP TS file, and then we copy what is being provided there. But for us, the endpoint is actually this. So we need to update this, or we put it in the .env file. But that's kind of how it's been set up. And then we, in the app providers file, we're trying to create a file called it's a TSX file, so provider TSX, and you put this one in. So we kind of put the provider probably, and the first like a file define this create Apollo client like a function is actually being used in the second file. So you need to read that, and then inside of the layout.js, we need to import the provider and initiate this provider thing. So inside of our layout, this is a layout, and it has so many settings. Let's try to say if we create it like this, it's actually wrong. Then oh, it's providers. I name it wrong. So yeah, that works. So until now, we should be able to, according to the instruction, we should be able to get it set up properly. So the Apollo client actually being set up this way. So in the Apollo provider, it's have the client, and the client was being initialized by the create Apollo client function. Then we need to pour the data. The example it given is in the page.txx and have these GQL things in. Then we can follow what they have put there. And we go to our layout page.txx and we do it this way. And it definitely not working because we don't have this example table. So we will go here and what we want to get probably is just the patient tracking. So we go here, we initialize the patient tracking. We want to know updated at the description count and create it. We copy this query to the one here. And you should always give it a good name. For example, here we give the name is get a dashboard or patient tracking. And then we should give this variable to be the same to get it consistent with the naming. You can name it as any like conventions you want, but ideally it should be consistent. And after this, you should be able to either see the loading, see the arrow, or see the example data in our page here. But here we see the arrow, which means there are something wrong. It's actually because of permission. So we need to go here. We go to the permission. And wait a minute. Oh, I think it's because in the settings of the Django. That's a permission things. Actually, I want to talk about it later. Not today. It should be tomorrow. So the settings should be delayed tomorrow. But here is we will try to update the Hasura settings here. So we need to ask the Cloudy. This is my setting for Hasura. I get the endpoint be public. I think there is a parameter control that. So wait. No. Maybe it's because of this. Let's try. Actually, I have enabled the anonymous mode. But are these correct? Yes, this is correct. That's bad. So it's needed to create the role for the anonymous. So I need to think. Let's ask another question. So like it's the same as a development environment as us. It's like you will normally have a lot of different problems like this comes out. So okay, let's try to do it here. So I think it's add a new permission and select without any check. This is row level and column level security I was mentioning, and we will talk about it tomorrow. And then let's see whether this page should be updated probably. Let's try. Okay, yeah, that's done. So just another problem is because of permission and because we haven't set up different layers of the permission. So in the front end, it's anonymous. We haven't do any login or query. So we want to be able to query the data. So you can see the data actually being queried to the front end now here. And if we want to update this query to actually also provide for the data from the dashboard image data, then we can update our query, right, into this way. Then if you test it in this interface and you find it's okay, it's ready to go, then you can copy it into the front end here. And that's the get. The problem is we want to show you the real-time dashboard. That's where the subscription works. So we actually want this to be subscript. So let's try to update this code here to show you how to do the subscription things. So then subscription, we're using a different class as a query. So this is how you get the subscription. And what's the error with being shown up here? Oh, there is no parameter. So we're doing this. And then the best practice is if you haven't used a variable, you should get that removed. So in this way, you basically can see the front end. Oh, I haven't actually set up the WebSocket connection, so I need to tear it here in this one. So here is just to do the HTTP setup. So I also wanted to set up the WebSocket connection for subscription and see what the GPT was doing. In the Next.js. And yeah, it's give us an updated Apollo client creation thing. So we should copy it to there. Then we do the copy and we find our Apollo client thing. And what's missing? This one is missing. We needed the GraphQL package. So the arrow itself means there is no module was being found there. And I think it should give you the instruction. You need to install that package. What's the package name? It should be the package as it's described it. So let's search. What's the package we need to install? I think it's just this name. So what we will do is the same as before, npm install, and then package name, and to see whether it's find that package. And we can see inside it just now is with HTTP. We just set up the HTTP connection. We haven't set up the WebSocket connection. So this update actually doing the WebSocket connection was set up. And before was it were doing some dispatch. So you split the like links. So which kind of links it should goes to based on like what's the protocol you requested. This is what's this link doing, and then the whole thing was being set up again. So after this, you should be able to see the subscriptions actually being being set up properly. So you see the data here, but the page looks a bit ugly. So let's try to ask the ChatGPT give us a better page. So we will ask, can you get the data demonstrated in a table format, not this JSON? And then it should be able to generate the data we can use in the front end. Because it's a Next.js, so it's kind of as Hao-Ling was described it, it's using the Tailwind CSS. This is how you use that. But you also have other packages you can use just import a component in. So that's the data is created. Let's try to copy and put that in to see whether it's compiled properly. It's has a problem, seems. See what's the problem in the front end. Oh, no, it's actually working, but it's not looks that good. So I think it's because I haven't set up the CSS, but I probably want to use a UI component as we already there. Then we will show you some of the React UI components you can use. So for example, this MUI, that's something was used, like implemented for the, like based on the material UI design patterns published by the Google. So if I want to get something looks very fancy like this, all I need to do is install a package and use a component to do that, implement a component. So we can ask a ChatGPT to do that. Then I wanted to use this package component. Can you give me the instruction how to set it up? And also update the table with the component within this UI. So you can see it's giving you the instruction, what's the package you need to install. And we will do as it instructed. And then it's also ask us to add this link to this CSS style to get, I think this one is a front for the CSS file. So it's ask us to update it in the layout TSX. So we just need to follow the instruction, go to the layout TSX. But we don't really have the header section here. So we need to add a header section here. And then we added the link in. That's the second step. And then this is a component is being created for the page. So we will follow it. But before we can properly use that, we need to do some setup. It says you need to create this theme.ts file in the app folder. So you will have the theme.ts file in the app folder. And you also need to have these providers in as a theme provider. So we need to update our provider file here. And hopefully it should be work. Let's try to npm run dev again. It says ready. It says it cannot solve this package. Let's try to see what happened. It installed the wrong one. Okay, and it's potentially because we haven't installed all of them. So no. Let's manually run to install it. MUI documentations and installation. That's a command it's given to do the installation. We copy it. So like what I just was doing is basically I know what I'm trying to do. So I keep asking Cloudy to generate the command I need to use for what to achieve what I want to do. But just now you can see it's actually hit a problem, which is some of the package dependency problem. So it's giving the error says the module haven't been found. When you hit this kind of problem, you need to exactly know what happened in which part, especially when you are the junior developer. So you need to understand what you want to achieve and get that very clear in your mind. So currently for me is I want to install these packages. And the command ChatGPT give me haven't worked. Then what's the other alternative ways I can achieve this? Then as a pretty standard developer, I know if I hit these kind of problems, if I cannot solve it, then I definitely can go to read their documentations and trying to get the problem solved. That's what I'm trying to achieve there. So you can see this is a dashboard pages is trying to like being created. The image actually failed because my image doesn't like the image ways to do the presentation is actually not the standard way to show this image. It need to call a specific like endpoints. We'll show up that later. So we just remove that image part. But what I want to show you later is about this real time because it's a subscription. So if where is my execute for time image. So this is a subscription. Like when you go to the hospital, you have see probably a big screen in the left side or the right side of the hospitals, like a triage emergency room, and you want it to keep updating. That's the user scenario we have mentioned from the very beginning. This will means if you have a new record being added in the database, it will show up in the front end. That's so I'm not sure whether you have seen that, but we can do it again. If you have something in the database being updated, you can see it from here. No matter how you get that being updated in the database, just know we just use the Django admin to insert the data to it. But we can also using this like this interface provided by the Hasura also to insert a row into the database. For example, here discretion test something or 10 and the integer. But you can see it here like this one is not that user friendly. I won't be able to directly insert one in via this interface because I haven't set the default value to this one in the background. Please see the powerful things for the Django's backend. But if I update, I can definitely update something here. So for example, this record, I think this is the record with 10 count. This is the record. If I update it here with some other descriptions, you can see it. It's actually being updated. So this is basically you have a very powerful and real-time dashboard directly from what we just have done. It's very easy and simple. And if we want to get this dashboard page to look much better or doing more modern, it's already more modern than the first version of it, right? Because the first version of it doesn't have any CSS. But with these packages we imported, it have this all of the functionalities. So you can do a lot of things. Like if we want to create a new page in the front end, let's try. I think we will do another like function demo here for the mutation. So can you update? I think I will give it the latest page information. So where is my code? Can you update this page with a plus button? And the plus button should allow me to add a record for the patient tracking. So normally the front end over the behaviors you are doing there is about like a create, update, or delete. So that's how it works today. Like when you're trying to build a functionality in the front end to add a button, say plus, and add some data for me. Originally, I think when I was a developer, it probably will take us 1 week as a team to get that done. But let's see whether this Cloudy wins in the first round. What's the 30? Okay, I don't have this. Then I need to install this package actually. Does it give me the command to install it? It haven't win in the first round, which means we still can survive. Let's give back the arrow to it. I think they changed the package name. Module not found. Okay, it's giving the command to add the package. Let's see whether that works. So you can see actually the load have the same problem as what we faced and mentioned in the Django section, the dependency things. But because this open source community is more active than the Django one, so it's actually solving much better. Okay, you can see it's actually like a get it win in the one chunk. So when we click the add, for it to add it, no, it won't because I haven't hooked it with the backend. So okay, but all the UI is already there. We just haven't added get the handle add function, handle submit function probably running there. So here is the description and the count, and let's check it. So it says insert this one and things, and it's give us arrow. Let's look in the arrow first. There is no mutation like this exist because our command is actually not correct. So we need to give it a proper mutation command. So let's go to here and add a mutation. We want to insert the dashboard patient tracking. This is what we want to insert, and we want to have a parameter called description, and it should be what? Should be string. Yeah. So this should be the same. And we have another is count as a int, and we will want to get a description equals to description, which is passed by the parameter, and the count equals to the count we pass in. And if we do this, it will say, okay, you don't really have a variable there. So we need to give it to the variable to test whether this one is working in this interface. Count 10, and you click it. What's the error? This error says missing selection. Oh, it's need to return something. Affected rows. What's the error? Oh, it says the created at relation violent the not a known constraints in the database. So we needed to give it the default value. So what I will give it is null. And you do the null here, and then we do the click. It's creating this data, which means our this mutation is correct. So we copy it, we put it there, and the mutation we clear is add patient tracking. And I will say this time it still won't work, but we will give it a try and see what's the error we're saying, because I know why it won't work. Let's go to the refresh. So you see this page, and you have this. We can pipe it in and do the add again, and it have another error. Oh, it still says no mutation exist. I think let's check the console. That's Apollo error. It's because of the data in the data of the patient thing here. Permission. Just now we just give it permission to do the select, but we haven't give it the permission to do the insert and update. You need to manually do that. And let's see whether this time it will work. Yeah, it's working this time. So it's a permission problem. Just in case you haven't seen that, we do this is updated record. Count is a very large count, and that's it. It's in. So we also showing up you how to doing the mutation creation here. And then you can kind of getting the hint from this. You can have a like an edit button here. You click it and you show the edit page like it was a Django admin already provided. But like you can implement this in the React itself in the front end by yourself, and trying to get familiar with how you're doing these kind of communications by yourself. So I think that's all of the demo today. Oh, probably I'm also forget one thing. Remember, just now we actually doing a lot of permission updating here, like the update we probably want it to be able to update any columns with a public. So we do this like changes of the metadata. Then we also want to explore our native metadata out. Then we also need to run the command later. Always remember that doing that things. And afterwards, you should be able to see the changes actually there in the GitHub, like a track. But eventually, we get this all of the things being demoed. We define a data module. We actually define two, and we run the data migration in the Django. We track our created table and relations in the Hasura, export the metadata out, and import them in. We set up the Apollo clients in the front end and also WebSocket connection in the front end. We demonstrated the subscription gate and the mutation things. So go back, like try it by yourself as a homework. And if you have hit any problems, just send me a message. I will help you solve that out. It should be simple and standardized nowadays to solve these problems. And I think that's all for today. Is there any questions for today's section? Questions? No? Then you should go back to start to do the implementation, because until now today, we actually have all of the information being delivered to build it locally in your own laptop for a project. The other two things we will mention tomorrow and the day after tomorrow is authentication and the DevOps. That's the other two things make your project more production ready. So you need to control who access what and how to deploy it. But until now, all of the components in our full stack is already been delivered. So you should be able to start implementing your full stack projects now. So good luck. And if you guys have any questions, let me know. I'm happy to help. And see you guys tomorrow.
Thanks a lot, Pascal.
Okay, see you.
Yeah.
Recording, stop recording.